Hello 8th graders, today we're going to wrap up our last lesson for this unit and we're going to summarize all three of the laws together, all three of Newton's laws. You actually will not need your notebook today, so you can set that aside, no notes page, no practice page for what we're going to do. Our job is to be able to do two things, review all three of the laws. So we've talked about Newton's first law way back at the beginning of this quarter. We're going to go back and review. And I also need you to be able to apply these laws to real life examples. So I'm going to give you some examples of something happening, some motion, some objects doing something, and your job is to be able to say how all three of Newton's laws are at work in those examples. In order to start, we're going to get a new voice in to kind of summarize Newton's third law. Since this unit is Newton's third law, I figured it'd be a good time to get somebody else in there to explain what's going on with that. So, in Google Classroom, there is a document that is for Professor Dave Explains the Third Law. Here's what it looks like. Your job, of course, is to fill in all of the blue squares as you listen to Professor Dave. The link is in Google Classroom. It's also at the top of this worksheet, and it's just these four parts right here. Come back and continue this video when you are finished watching Professor Dave. Now that you've had a refresher on Newton's third law, let's quickly talk again about the other two laws just to make sure that we're reminded of how they all work before we go into the next step. So Newton's first law was the law of inertia, and inertia is the same as mass. Those two words mean the same thing. We use the word mass to talk about how much stuff is in an object, and we use the word inertia to talk about how that stuff behaves. So if you have a really big heavy thing that's at rest, it's going to tend to stay at rest, and it takes a lot of force to get that to change. Same thing with objects in motion. If you have an object in motion, it's going to tend to stay in motion in a straight line, and it requires force to do that. The amount of mass in the object tells you how resistant to changing it's going to be. If it's at rest and it's light, it's not so hard to make it change what it's doing. Same thing within motion. Newton's second law, the green row here, Newton's second law talks about, well, what is an object going to do when there is a force? How is it going to change? And it's all about acceleration. Newton's second law says that for every force, depending on how much mass it has, you can figure out how much it's going to speed up or slow down. So big forces make for bigger accelerations, and the mass affects that. The bigger the mass is, the harder or the slower it's going to accelerate. And then, of course, what we've been reviewing just now, Newton's third law. For every force, there's an opposite force. So if the car is going to push on the ground to get going that way, that means that the ground technically got pushed in the opposite direction. And as we've been talking about, momentum follows the same rules. If something gains momentum going one way, then there has to be an equal momentum going the opposite way. Momentum always is the same before and after a crash. Your job right now is to go into the concept check where you're going to get some examples of things in motion or things at rest, and your job is to say whether or not you think it best shows the first, second, or third law. So pause this video, go into Google Classroom, and open the form now. Now we are on the last step. If you are still watching, you have watched Professor Dave summarize Newton's third law. You have gone through the Google form and you've tried some and looked at your answers. And now it's your turn to come up with an example for all three laws. Your task is to demonstrate that you understand the difference between the three laws. In order to do that, the requirement is that you come up with one real-world example for each law. Not only do you need to come up with an example, you need to explain why and how it's an example. You can't just say, this is an example of first law, and then you're done. You need to explain why it's an example of the first law. Here's how you can do that. These are just some ideas I came up with. You could make a short video. You could take some pictures. You could draw a picture. You could go find a picture on Google. You could make a computer animation or some other creative, clever idea that I haven't thought of an example to show, or a way to show an example of the law. Once you have found or made an example, then you have to explain it. You could do a voiceover for your video. You could add text to your picture. You could write a paragraph and attach it. You could record your explanation using your voice in a Google slide or in the speaker notes or some other creative way, but you must explain how it shows the laws. If at any point you're like, I'm not really sure I'm sure how these laws are different, in Google Classroom, I have left a video of Professor Dave for first and second law. They're very short. You can go and watch a refresher for those. There's also a note sheet which is just a one-pager that you can read about the three laws if that helps you too. Let me show you an example of how I did this assignment. So I went out and I took some video, and these are just screen captures, some pictures from that video. You could turn in just a single slide in like a Google Slides presentation, just like I have on your screen right now. Here's my example on the top left of Newton's first law. I have my son pushing me and my daughter sitting on a skateboard. Because we're both at rest and I have more mass, it was way harder for him to get moving. You can see how he has to lean into it, whereas my daughter is lighter and he didn't have to push as hard. And I've explained that off to the side here in the blue box. For the second law, this is the one about acceleration. Once he did get us going, my daughter was able to accelerate much more with his force than I was, again, because of my mass. So you can see how she beat me to the left side of the screen, and I'm still trying to catch up. And I've explained how that applies to second law in this box right here. And then, of course, third law. This is my daughter sitting on a skateboard. In order for her to go to the left, she had to apply a force to the right. So when she pushed on this light pole, the light pole pushed right back, and her momentum going to the left is actually the same as the Earth's momentum. She technically changed the Earth's momentum. It's by like a ridiculously infinitesimally small fraction, but technically, according to Newton's laws, she did. And this is how I've shown all three of my laws. I've also done it in video form if you want to see how I did that. Here's how I did the videos. Now that you've seen my examples, it's time to pause this video for the last time and go and make your examples for Newton's three laws and attach it to this assignment when you're done.